Welcome to Study Loop.
So in this problem, we will use one very important fact. And the fact is that the internal energy of the system is not dependent on the path, on the thermodynamical path of the system. So the system is going through certain changes, and these changes are given in the figure of this problem, are described with some path on the figure. Now, internal energy is not dependent on the path, so we can easily evaluate it just using start and the end point of the path. So only the beginning and the end of the path are important for the value of the internal energy change. And we can immediately derive the internal energy change from this law here. This is the first law of thermodynamics. So from here it goes that this is for the part A of the problem, that the change from A to B, this is from 2 points. So this is the change, this is essentially meaning internal energy at the point B minus internal energy at the point A. This is the change here. So delta UAB equals, and from the first law of thermodynamics, we know that this will be equal to Q minus W, or the heat minus the work done. So in that case, AB will be equal to 90 joules minus 60 joules, and this is equal to 30 joules. So now for the path from A to D to B, for this path, to find the corresponding heat for this path, we can just directly substitute this evaluated internal energy change and add it to the work corresponding to this path. So Q A D B equals delta U A B plus the work corresponding to it, and this is going to be 30 joules plus, now substitute the work done, which is 15 joules, and the final answer is Q A D B equals 45 joules. And this is for the part A of the problem. Now we have two other parts. We have the part B and the part C. So for the part B, we need to express that if we invert the end and the start point, the internal energy will not change in its magnitude, but in its sign. So the sign will change. For example, UBA will be equal to minus UAB. And since we already know the value of UAB, delta UAB, this will be equal to minus 30 joules. Now, since in this case the volume will be decreasing, the work done corresponding for this part of the problem is going to be negative 35 joules. And to evaluate the heat corresponding heat will be delta U plus the work done. Now we will use, notice, we will use this change of internal energy and substitute it here, and we will use this work and substitute it here. So this will be all negatives. Negative 30 joules plus negative 35 joules. And this is equal to minus 65 joules. So the final answer for this part of the problem is that Q equals minus 65 joules. And this means that the heat is getting out of the system. It is being liberated from the system, which is corresponding to this part of the problem. Now for the last part of the problem part C. So here we have taken into account what happens from the point A to the point D directly. So the work done from the point A to the point D. Notice that this work is equal to work ADB. And we know that this work, or already evaluated it in the part A, is equal to 15 joules. So the heat corresponding from A to D is going to be QAD, and this is of course going to have internal energy change from the first law of thermodynamics corresponding to AD plus the work corresponding to these 2 points, and this is going to be the internal energy at the point D minus internal energy at the point A. This is the beginning point, and plus the work done. So here we know that this will be 0, and we can substitute this to be, we know this is 15 joules, and we know that this is going to be 8 joules. So this is going to be 15 joules plus 8 joules. This is corresponding here. And the final result for this part is that QAD equals 23 joules. Now this is not the end of the part C. We have another path, and this is the path from D to B. So again, in the same manner, we will say that internal energy change from D to B is equal to difference in internal energy values in the point B minus in the point D, and this is going to be 30 joules minus 8 joules, which is equal to 22 joules. And very important thing now, the Q, total heat, from D to B is from the first law of thermodynamics, delta U dB plus W, and the work done in this case is 0 from these two. So this is, you can see this from the figure given in the problem. So this is going to be just 22 joules plus 0, and therefore the Q from D to B is going to be equal to 22 joules. And with this, we have finished the part C of this problem. And the whole problem is now solved. I hope you find this helpful, and I hope to see you in another lesson.